Hey everyone, let's knock out 2 more sandwich theorem problems. For an example 3, I'll just let you know the answer this time will not be 0. Limit's still approaching infinity, right? Or I should say x is still approaching infinity, but the answer will not be 0, so let's take a look. Remember, we want to start with the trig function. So you can just say that sine of x, which is, sine of x is less than 1, and it's also always greater than or equal to negative 1. This is the same for sine of 3x. Remember, sine of x and sine of 3x, right? The 3x just affects the period. It doesn't affect the amplitude of sine of x. So you can include that 3x from the beginning. You also can include the negative sign, right? Just include the negative sign, right? Negative sign is still bounded by negative 1 and 1. So give yourself a head start and start with that. And then what we're going to do is we're going to multiply, or I shouldn't say, we're not going to multiply, we're going to add 5x to both sides, right? So we're going to have 5x minus 1 less than or equal to 5x minus sine of 3x less than or equal to 5x plus 1, right? So we get that 5x. Then at this point, you might guess what we're going to do. We're going to divide by x plus 27, right? Or multiply by 1 over, right? So this is going to give us 5x minus 1 all over x plus 27 as our lower bound. And what do you know? We have the original function in the middle here. Remember, that was the entire goal of all this. And then on the right, we have our upper bound. Great. The only thing we have to do is check. Make sure the limits of the lower and upper bounds are the same. If we are, then we're home free. So the limit as x approaches infinity of 5x minus 1 over x plus 27. Well, remember, that's going to give us infinity over infinity, which is not so great. But remember that we can divide the top and the bottom by x or multiply by 1 over x, and then that's going to give us the limit as x approaches infinity of 5 minus 1 over x over 1 plus 27 over x, and that equals 5. And then note that you can do something completely analogous with the plus, right, with the upper bound. That's the only thing that'll change. So I'm going to go ahead and leave that to you. Actually, no, I'm not going to leave it to you, but I'm going to cheat a little bit. Do a little bit of copy pasting here. Copy, paste, right? And then just kind of say, well, actually, we got a plus and a plus, and we get the same thing. So yes, they equal the same thing. And so remember, we always have to say, by the sandwich theorem, we have limit as x approaches infinity of 5x minus sine of 3x all over x plus 27 equals 5. Not 0 in this case, but it's 5. Okay? So that's how you do that problem. And lastly, in example 4, this is a little different because we're approaching 0. But if you take a look at the graph of cosine of 2 over x, when you approach 0, it gets really crazy and haywire. Okay? So we have to see what's happening at 0. And again, we're just going to start off with the trig function. Even if you didn't know that's how cosine behaved, we're just going to say that cosine, no matter what's on the inside, is bounded below by negative 1 and above by 1. Okay? And then what are we going to do? We're just going to multiply by x squared. So we're going to get negative x squared less than or equal to x squared cosine of 2 over x less than or equal to x squared. Okay? And what do you know? We've got our original expression. Awesome. Original function, right? Now we're going to check. And this one shouldn't be too bad. Limit as x approaches 0 of x squared. I should say of negative x squared. Let's start with the negative first. Doesn't really matter. turns out that equals the limit as x approaches 0 of x squared, and that's just 0 squared, which is 0. So by the sandwich theorem, we have that the limit as x approaches 0 of x squared cosine of 2 over x equals 0. So we do have an answer of 0 in this case, but note that here x was not approaching infinity. And just to show where we were going with this, let's quickly graph this, because I think this will be a nicer graph, right? So we have, or I should say actually, we have x squared times cosine of 2 over x, right? So you notice that, right, when we get close to 0, stuff gets a little funky there. Also note that we could have negative x squared, y equals negative x squared, and if we could have positive x squared, oh, that's kind of cool, right? There you go, diagonal, right? Okay. So now look what happens, right? The purple function is the one that we're examining, and that's going nuts. But it is still approaching 0, and we know that because it's being bounded below by that black function and bounded above by the red function. So let's just paste that image right in here. Give it a nice little crop. And there we go. Where should we put this? Maybe a little tighter there. And there we go. All right.